The first thing that we're always going to do, I guess I'll put some steps here on the side, is we notice that we're solving for x in an exponent. And up till now, the only way we've been able to do this is if we used our powers chart and noticed the numbers were in the same column. In this example, I have a base of 2. On the other side of my equation, I have a 3. 2 and 3 are never in the same column of our powers chart. So what we're going to do is take the log of both sides. And we can take the log of any base. So I'm going to just put, you could take the natural log of both sides if you wanted to, or the log of both sides. Those are the two that are most commonly used because they're the two on the front of your calculator. You don't have to go to that log base and use a new base. Plus, they're also nice because the log of base 10, the common log, you don't have to write the little number each time. Saves you a little bit of time. If you really want to be efficient, use ln. It's one less letter. And that maybe save you like 0.8 of a second. So now that you've, oops, I guess this is a 3. Now that we have taken the log of both sides, the second thing we're going to do is we're going to use our log laws. I'm going to just say, to get x out. We want x out of the exponent. That's the whole problem this is hard to solve for, because x is in the exponent. So our log law says if we have an exponent inside of a log, it can come out in front. If that exponent is to the entire thing, which it is, it's to the 2, that x can come out in front. So by doing that, now we've changed this to a linear equation with ugly looking numbers. Log 2 is a number. Log 3 is a number. Ooh, is log 2 0.301? I'm starting to try to memorize my logs. Check. I don't have any idea what log 3 is. So now if I divide both sides by log of 2, was it? Anybody checked it yet? I'm terribly curious. It is 0.301. Good. I've got 1 down. Now next one I have to memorize the log 3. So log 3 divided by log 2, we can go to our calculator, type this in exactly as we see it, log 3 divided by log 2, and we find out that this answer is 1.585, rounded to 3 decimal places. So we used our log laws to get x out of that exponent. Our third step was we used our skills to solve for x. In this third step, I'm going to write factor if more than one x, because that's going to come up. Sometimes we have x's and exponents in more than one spot, and so we have to factor if there's more than one x. So we'll see what that looks like. But this is the basic idea. We're going to take the natural log or the log of both sides to allow us to pull that x out of the exponent. This one was the most basic one because there's only one log law that needed to be used. Some equations you're going to have to use all of your log laws. And so they're going to get more complicated than just this. But you get that x out, and then once that x is out, it changes to a regular equation. Sometimes you don't recognize that as a regular equation because it's hard to recognize these things as just numbers. Log of 2 is a number. Log of 3 is a number. So we've got a number times x equals a number. Super easy to solve for, except it's a little bit harder just because you're not used to what they look like. So here's our next one. We have our x in our exponent. Notice the difference here is that there's a 2 out in 2 times 3 to the x. So if I take the log of both sides, or the natural log if I want to save 0.8 of a second each and every time I write it, I would get this. All of those questions that got you to expand completely, all of that work that we did prior to this was for this reason. In order to get the x out of the exponent, it's part of expanding something completely. Now, when we expanded something completely, like we have on the left side here, we have to decide, what can we do first? Can I bring the x out in front already? Or do I have to do, since there's multiplication here, do I have to do the adding thing first? In this case, you're going to have to do the adding thing first, because the power rule, to bring the x out in front, that only works if that power is to the whole thing inside of the log. And right now, that x, that exponent of x, is only to the 3. It's not also to the 2. So we would start by saying, well, then this is equal to natural log of 2 plus natural log of 3x, because we're multiplying, equals natural log of 5. And now that x can come out in front. And this is now in a state where you can solve for x. You've got to remember that each of those logs are just numbers. Number plus a number times x equals a number. What would you do if you were solving a normal equation? If you had a number plus a number times x equals a number, what would you do? You'd put your numbers together. They're like terms by subtracting. The only thing that's different is when you subtracted 2 on both sides, you could do the mental math, and make another wonderful looking 3. Okay, that's bad. Because 5 minus 2 is 3. Here, when we're doing our like terms and I subtract the natural log of 2 on both sides, well, I don't know what number that is. I'll just leave it like that for now. Just like you could have left that as 5 minus 2 on the other side. And then to get x by itself, we just need to divide by the natural log of 3. So we've got x by itself. We can take out our calculator and find out what this is as a decimal. So I like to use the fraction button because we have a lot of things going on here. So then you can type it exactly as you see, natural log of 5. Notice how your calculator starts with a bracket. You have to close the bracket. Minus natural log of 2 divided by the natural log of 3. Push enter and we get our answer, 0.834. Notice in your notes, we got the same answer using log, right? It's the same answer, and all the way through, they took the log of both sides. Here we took the natural log of both sides, but it works out the same. If you want to check to see if your answer is right, right above your on button is a store button. Push the store button. It says, where would you like to store that answer? You have an option of any letter you want, or if you want to be quickest, you can just pick X and store your answer as X. What this allows you to do is to check if your answer is right. What did we have originally? We had 2 times 3 to the power of x. That is what was on the left side of our equation. If I push enter here, and this is equal to 5, then we know that we've got it right. So the really nice thing about solving for x in exponential equations, and the reason why your homework on the back has no answer key, is because I need you to check. Every time you get your answer, store it, plug it back in, and then you'll find out, did I get it right or did I make a mistake? Because if the two sides aren't equal, then there's a mistake somewhere. So this one a little bit more involved than the first one because we had to apply 2 log laws and we had to expand it in the right order. We had to know that you had to deal with the multiplication first, so you added first and then brought the exponent out in front. Some people, as they get really, really good at these, can you see yourself going directly from this step to this step all at once? that you could see that you needed to add, and, oh, I'll bring the x out in front afterwards, and that's fine. Our last example here, we have x's on both sides. So this one is going to be not quite the most involved, because I could make it even a little bit more with log laws, but this is our first one that has an x on both sides. So let's say you take the log or natural log of both sides. Pick one. You want to do the log of both sides or natural log? Log? Okay, so we'll take the log of both sides. And I'm going to take things slow. I'm not going to do any exponent laws yet. Just took the log of both sides. Now, I want my x out of the exponent, where right now this x minus 1 is the whole thing, so I can bring that out in front. And I'm going to need to put it in brackets because there's more than one thing there. So that x minus 1, when it comes out in front, I'm going to need to put that in brackets. Same thing on this side. The 2x plus 3 can come out in front. Now, log of 5 is a number. Because log of 5 is a number, I can distribute it. If I distribute this log of 5 to both of those, I'm going to get x log 5 minus log 5. Same thing on the other side. If I distribute this log of 3 is a number. I can distribute it. I'm going to get 2x log 3 plus 3 log 3. Now, it looks really complicated right now. It looks complicated because you've got a bunch of disguised numbers. This is a grade 9 question that looks like this. 3x plus 7 equals 2x minus 3. We've got x's on both sides. We've got numbers on both sides. So what did you do in grade 9? You combined your like terms. What are we going to do right now? Same thing. We're going to combine our like terms, but we just won't be able to put them together. So it's kind of not really combining like terms if you're not able to actually put them together. But the idea is, let's get our x's on one side. Let's get our numbers on the other side. That's kind of like combining our like terms. So I have an x log 5 here. My other term with the x is there. I'm going to subtract that on both sides to get the x's on this side, and I'm going to put my numbers on this side. So I had a 3 log 3. I'm going to have to add log 5 to both sides. Now my numbers are on one side. My x's are on the other side. And since I can't do the mental math to add log 5x and 2 log 3x together, I'm going to factor. So in our note at the beginning, when you have more than one x, you can say there's an x in common between these two. I can take that out. That'll leave me with log of 5 minus 2 log of 3. And on this side, I'm left with 3 log of 3 plus log of 5. And it's just a really long way to write numbers. Now, how do I get x by itself? Because this is x times a number. I would have to divide by that number. So my final answer is 3 log 3 plus log 5, all divided by log of 5 minus 2 log 3. Whew. There's a lot of stuff there. This is where if you have your calculator and you're able to use the fraction button, use it. If you don't have the fraction button, you are going to need an extra set of brackets on the top, an extra set of brackets on the bottom. So I'm going to go to my fraction button. I'm going to type this in exactly as I see it. 3 log 3 plus log 5. Oops. All divided by log 5 minus 2 log 3. Enter. So we get an answer, negative 8.34. I want to know, is this answer right? So I'm going to store this answer, hit the store button, just choose x again, And it doesn't matter what you have stored as x. If later on you're going to graph, it doesn't affect that anywhere. So whatever your x is stored as will have no effect on anything other than any kind of arithmetic you want to do with that x. So what was our question? I've stored it as x. What was my question originally? On the one side, if I go back, I had 5 to the x minus 1. So I type that in. 5 to the power x minus 1. Again, if you have the newer operating system, you don't need brackets around that. If you have an older operating system, you'll need brackets around that exponent. And I find out what that's equal to. Okay, 2.93 times 10 to the negative 7. Interesting. And now I'm going to check my other side. My other side was 3 to the power 2x plus 3. 3 to the power 2x plus 3. And this is where you get a little bit nervous, right? Because we've just spent 5 minutes on this question. The numbers are wrong. It means I've taught you everything wrong, probably since the beginning of the year. Oh, phew. And they're the same. So since our left side when we plugged x in and our right side are exactly the same, you know that that answer of negative 0.8345 that answer is correct. And using the store button stores all those decimal places for you. If you had rounded early and then plug it back in, your answers will be close but not quite the same. But in this case, when we plug them into our calculator, they are identical. So all of those practicing expanding, our expanding practice was so that when we get to these kind of questions, we can get the x out of the exponent. And then we just need to rearrange to get x by itself. These, the hardest ones here, you have to factor that x out. But it's basically using your grade 9 skills with numbers that you would never have seen in grade 9 to be able to solve it. Okay, so on the back side of that page, there's an exercise. There's just one question, but it has all the way up to ABC, up to I. Again, once you get your answer, then plug it into your calculator, store it, and check it to see if you got it right.